All right, for number 41, we're given this function, f of x equals 3x to the fourth minus 22x cubed plus 13x squared plus 118x minus 40. And then we're also given these two binomials, and we're asked to use the factor theorem to determine whether either of these or both of them are factors of f of x. And if they are, then that's going to be great, because that's going to help us to factor this down, because then we'll know that that either of these or both are factors, and then we can use that to factor f of x. Now, the factor theorem says that if we divide this by this, this is going to be a factor if and only if the remainder is 0. So that's how we're going to test whether or not these are factors, is we're going to divide them and see if we get a remainder of 0. All right. So the first thing we're going to notice here is that we've got 3x minus 1. We've got a coefficient in front of this x. That's a problem because remember we said that we can only use synthetic division if we don't have a coefficient in front of the x. If we have something like this, we can use synthetic division, but not for something like this. So we need to make this look more like this. We need to get rid of that 3. So let's think about this in terms of what we're trying to do. We're trying to get 3x to the fourth minus 22x cubed plus 13x squared plus 118x minus 40 divided by 3x minus 1. And we don't want that 3 to be there. So what we could do is we could divide the top and the bottom by 3. Or, in other words, multiply the top by 1/3, and we could multiply the bottom by 1/3. And we can do that because 1/3 divided by 1/3 is just 1. We can multiply anything by 1 without changing it. So the top, we're going to end up with 1/3 times 3x to the fourth is going to be just x to the fourth. 1/3 times this is negative 22 over 3 x to the third. 1/3 times 13 is 13/3 x squared. 118 times 1/3 is 118/3 times x, and then minus 40 over 3. And then what that gives us on the bottom is x minus 1/3. We've got to multiply that 1/3 across there as well. So now this is something we can do with synthetic division. All right, so let's take all of these coefficients and let's put them in our synthetic division. So we got 1, negative 22/3, 13/3, 118/3, and negative 40/3. And we're going to divide this whole thing by x minus 1/3. So we're going to put 1/3 up front here. All right, so drop down the 1. 1 times 1/3 is 1/3. Negative 22/3 plus 1/3 is negative 21/3, which is negative 7. Negative 7 times 1/3 is negative 7/3. 13/3 plus negative 7/3 is 6/3, which is 2. 1/3 times 2 is 2/3. Plus 118 over 3 is going to be 120 over 3, which is 40. And 1/3 times 40 is 40/3. And 40/3 plus negative 40/3 is 0. So we got a remainder of 0, which is what we wanted. That means that this is a factor of this. All right. So Let's try x minus 5 now. Now notice that we've divided 3x minus 5, or 3x minus 1 out of this. What we're left with is x to the third minus 7x squared plus 2x plus 40. And so if x minus 5 is going to be a factor of this, well, it's got to be a factor of this, of x cubed minus 7x squared plus 2x plus 40. So what we can do is just do our synthetic division on this one with the 5. And that's going to really help us in the end, because now we know that this is a factor. If this is a factor, we've almost got this whole thing factored. So bring down this 1. 5 times 1 is 5. Negative 7 plus 5 is negative 2. Negative 2 times 5 is negative 10. 2 plus negative 10 is negative 8. Negative 8 times 5 is negative 40. And look at that, we got a 0 in our remainder again, which means that x minus 5 is also a factor of f of x. And what we're left with now, we started with x to the fourth, we factored out an x, so this became x to the third, and now this is x squared. And so let me write this. Now, these are both factors, so I'm going to take away that comma, and we have those two multiplied together, and what we're left with is 1x squared minus 2x minus 8. All right, and now I'm going to get rid of all of this and give myself room to now complete this factoring. So 3x minus 1 times x minus 5. And then we need two numbers that multiply to negative 8 and add to negative 2. So that's going to be negative 4 and positive 2. And now we have this whole thing factored. So that is the complete factorization of f of x.